some of you really fake the funk on this homework side. And I'm just telling you that I'm basically done playing the game with you. It gets down to at some level that there's just kind of this game of school that you start playing. I'm not playing. So, I'll give you credit for tracking homework. You really want that homework, you want that 5 on your homework, I'll give you credit for it. I'm done having the conversation with you. And then when you have all your homework turned in on time and you failed the test and can't do any of it, your parents want to know why you have an F in this class. We'll say, they're like, but they do all their homework. I'm like, yeah, go look at it. It's terrible work. Crap. But that's okay. If you want to make that choice, then absolutely you will. You will be able to. Okay, moving on to your sophomore year, you're going to have to accept the choices that you make. Good or bad, right? There are consequences and positive, consequences and negative. If you want to do the game where you copy down crappy work or put down answers and do whatever, that's cool. Do that game. Let me know how it works out for you. Okay? It works out for about 2 to 5% of students pull that off. In a room this big, that's like 1 or 2. 24 of you didn't do your homework. Oh. So 1 or 2 of you, you might turn out, you'll still be all right. 24 of you didn't do it. Just saying. But I'm not even I'm beyond that. Your little 8x8 floor will be cozy tomorrow. But that's like I'm at the point of the year, just so you know, like I told you, we have like less than 15 days of math, 15 days of building, less than that. It's actually like I think it's only down to about 13 now. 12 or 13 days of each of the 2 classes. That's not that many. So if you want to fake it, be my guest. Fake it on your homework. It's 10% of your grade. You're not going to trick anybody except for yourself. Right? When I come in and I see like, oh look, that's weird, they did all their homework. Clearly they had no idea what they were doing on it. You didn't come and ask for help. You didn't put in your best effort. Right? You're not fooling. I'm just pointing it out there. Like if you want to lie to yourself, go ahead. Lie to yourself. I'm not going to fight you on it anymore. But know that you're not tricking me. It's very clear to me what's going on. But if that's the choice that you want to make, alright. Okay? I won't even, not even really going to comment on it. Nor am I really going to put my emotions into it. Because it's May. You don't care about it. I cannot care for you. Tried that game for the past 8 months. Alrighty? So, that's what I have to say about that. You know who you are, so that's just like internal look time. Look inside yourself. That's what you want to put out. That's the kind of work you take pride in. In a year we won't have class together. So you get your pizza party. We have a date picked. It'll be a surprise for you. Won't be it'll be a good one. We should do it on a day when we give it to people who are working.
Okay.
Students tomorrow. They had to buy half as many.
That's kind of a bad idea. We save some money.
Tomorrow.
That's messed up. You have the boldness to say that to me. Okay, that's messed up.
So it's 24 people not doing their homework.
Thanks, Leah. That's messed up. You had like 6 homework problems. You messed up. You couldn't do that. Okay. Get it? Alright, let's talk about this. 2 levels on this. Either. Now, I would have been nicer if I did nice numbers, but I didn't. So, the very first thing you're doing is trying to find that missing sideline. Ignore all the expressions. If you're confused, you're like, I don't know all this stuff. Ignore that and at least tell me how long this is. Right? In order to find out how long this is, we need to talk about a multiplier, a scale factor, like we've always done. So, I figure out my scale factor is 0.75. I know that 12 times 0.75 gives me 9, and I would use that same idea to say 16 times 0.75 is going to give me that length. 16 times 0.75 happens to be 12. So now I know my side length is 12, and if I'm going to finish solving this, we're trying to solve this equation. I'm trying to solve 3x minus 8 equals 12. Right, that's what I'm trying to solve. So, I will also warn you that yes, I'm going to go really quick talking about solving equations. Levi, can you draw your picture? I'm going to go really quick because how you get better at solving equations is by practicing solving equations. You don't get better at solving equations by watching me solve equations. Boring for you, boring for me. I'll go quick and I'll leave it up here if you want to copy it down. But general rules, you're doing the opposite and you're doing it to both sides. The opposite of subtracting 8, you know, adding 8. So I add 8 to both sides. I get 3x is equal to 20. And now right here, we're talking about this lazy mathematician. 3 times x, the opposite of multiplying by 3, is divided. So I divide both sides of my equation by 3. And appropriate answers here. You could write x equals 20 over 3. You could write x equals 6.
Okay, that's not the number.
You could write x equals 6.67. You may not write x equals 6.66. You may not write x equals 6.6 bars. Bars just kind of like, you used to, it's the same way, like, it's the same way you used to write the x for times, you know? It's kind of like, we don't do that anymore, we're grown. Getting a little fancy with our math. Those are 3 appropriate answers, all the same number. Again, like, I wouldn't even care if you just left it as 20 over 3. That's fine. X equals 7 gets you a open yeah. All right. So that's our first piece. Second piece. Wait. Hold on. You know, you're not leaving until 2:15. September 15. Yeah. Bus doesn't leave until 2:15. Bus leaves at 2:15. What? Right there. Tuesday, May 3rd, track, 2:15 to 2:30. Let's leave it to 2:30. Okay. Moving on to this one, again, using the relationships we know. There's an arc length. How does the inscribed angle relate to the arc length? Correct. Huh? No, they're not equal. Taylor.
The inscribed angle is half the central angle, which is the same as the
Cool. So the inscribed angle is summarized. It's half of what? The arc length, right? This is half of that. I hope you think of this next week. Okay. So what's that arc length right here then? What's this green length?
70.
70. That's the level 1. Figuring out, okay, that means that would have to be 70. And that means I'm trying to solve the equation 2x plus 7 equals 70. So in order to solve that, again, I'm going to go super fast. I'm going to subtract 7. 2x equals 63. So that when I divide both sides by 2, I get 31 and a half.
Oh,
Okay.
that's one.
31. All right. Quick, before the track and field players go, I want you guys to spend 6 minutes talking about your math homework. Now, that means probably about half your table did their homework. Now is the time for you to work through it. Now is the time for you to work through it. Yeah, get help if the reason was because you didn't know how to do it. You're getting help right now. If the reason was because you're lazy, then you're doing it right now. But I need that conversation centered and focused around math for 6 minutes. If you don't have a math conversation to have no conversation at all. Ready, set, go. Gigi. Make sure you have then step 2. Talk about which one
radius of the top, the way from 67 is radius. What the heck?
65B is 90 because A is the center of the circle. So this right here, half of a circle, that angle, half of a circle is 180 degrees. The inscribed angle is half of that 180. This is an inscribed angle. That's the definition of inscribed angle. These are all inscribed angles. If you was employed, it's this, right? If I have, and here's the center of my circle, ignoring that, that's the diameter, right? But ignoring that, if I have an angle here, this would be a negative. What's this angle? Right, this is 180 degrees, which means that this, hold on. This arc length is 180 degrees then, and we know the inscribed angle is half the arc length. Because that's what it means to be an inscribed angle. It's an angle on a point of a circle to two other points of the circle. You have an inscribed angle anywhere. You have one here, another here. It can be anywhere. It's just a point, the angle on a circle to any other point on it.
Sorry.
Okay, there they are. So 70, what else? B, D, E. Yeah.
Yes.
All right, what else? What else? Yeah, okay. So, well again, if this angle DCB is 6x, the angle is half of the arc length. Or another way to say it, I could say the arc length is twice the inscribed angle. Same thing. So if that's 6x, this has to be 12x. Because half of 12x is 6x. Looking at number 70. Terribly drawn semicircle. Okay, so, here. The rest of you gonna do? See you later. Bye, Bill.
This cub.
So, here's the piece. They want to know this piece right here. So if you found the inside piece, that was no good. I lied. That's the piece of iron that's going to be making the arch. So that's what it's telling you. It's saying that each of these pieces are 4 feet long. Yes? Right?
Oh no, I got really confused.
what?
Yep.
What did you say?
I got really confused looking at it because like I couldn't tell what part I was talking about. So if you look at the picture below, there actually is a 9 of those.
I don't think it's this though. I think it's this. This way. This way. This is the 4 feet long part. Basically, if you're finding, the goal is that you found circumference and divided by 2 of something. If you got like 26, is that what some of you guys got? What's the answer to that? 26? Or 56, I'm sorry. If you got around 56, that would be good. I don't know how you got 18. Oh, you're right. 18. Your actual diameter right here would be 20 feet. The actual diameter would be 20 feet, which gives you an actual radius of 10 feet. So the circumference is 2 times r times pi. It's going to be 20 times pi. So you get 62.83 feet for your answer. Oh, I wrote down the wrong one. Sorry. So when you divide that by 2 for half of it, you get 31.44, which is not what I wrote down. So I would say you should have that answer there, or you can also have $18.85. So depending how you reasoned about it, if you did the iron on the outside of those pieces or on the inside, this would be the inside piece for the iron, this would be the outside. Whichever way you thought about it. Alright. So, I have one question that I'm going to pose to you guys today. We're going to talk about that one question, and then we're going to use what we know about it. Okay? So here's my one question for you. You guys are going to spend a minute and a half individually thinking about it. But before you do that, let's put it in our notes. So, we are talking about G9 circle. And then we are talking about intersecting chords. What I would like you to do is to determine the relationship between the two triangles.
You can't see. Where's your glasses? The first step to recovery is admitting
For a
that you
minute and a half, sorry my circle's very oblong. For a minute and a half, I want you, using your own brain, to first think about, what am I even asking? Determine the relationship between the two triangles. There's these two triangles inside a circle. And 3, 2, 1, 2. One, thinking about what I'm asking. And 2, trying to determine what's the relationship and how you know that. Why do you know that? Okay? So I'm going to give you 2 minutes of individual think time on your own, thinking about this before we start. 2 minutes. Ready, set, go. Check it out. Circle, circle, dot, dot. Yeah. Okay, ready? Ready for this? This arc length right here is 140 degrees. What's that angle?
70.
We know it's 70 because why?
Yeah.
It's half. Okay. What's that angle? Wait, which one? The purple one. This one right here. Because why? Because it's about this one? $70. Fun side bonus question. How many inscribed angles are there with a degree of 70? In expanded. How many more could I draw? Huh? Right, like I could draw this one right here. There's one. There's one. There's one. Some of you guys are like, I'm about to start doodling. No, that's kind of cool. There's one. There's one. How many are there?
That's what it was.
There's more than 10 for sure. Anyone know how many
There's
there
at
are?
least 2.
Yeah, I know, we drew.
Active.
Alright, we'll come back to that one. But the point is, of all of those angles that I drew, what degree were they?
70.
70. Right? Because if they share an arc length, then they're the same angle. So when we look at this, if I look at this right here, BE, a terribly drawn circle. Which angles have that same, or which angles are half that arc length? Which inscribed angles? Which inscribed angles? Yeah. A, right here, right, if we ignore it, I can see that A is an inscribed angle for that arc. So A has a measure. And then the other one is D. So I can say because A and D share this arc length, they are the same angle. Right? Because they share that arc length, they are the same angle. Yep. So of course I can do that over here. I can say then looking at this arc length here, right? Which two angles have the arc length, share arc length AD? So looking at that one, right? There's B and E. Or I'm sorry, just B. There's B, and then I can look over here, and there's E as well. So those guys, now we can say, hey, all those angles are the same. Those two triangles are similar. And since we're talking about it, here's where we're going with that. Here is where we are going. If this is 4, and this is 6, and this is 9, find out how long that piece is. Because if we're talking about similar triangles, we're going to talk about missing sides. Find out how long that piece is, X. Tell me how long that